Welcome to the pre-lab lecture for determining the density of a solid unknown. This lab is so exciting we decided to put it into two parts. But don't worry, you don't have to wait. You get to do both parts in one day. You're going to determine the density of a regular solid and an irregular solid. For more of the exciting details, I suggest you move on to the next slide. Beep. Just a quick review. What is density? Density is mass divided by volume. So, if we're going to measure the density of an unknown object, we're going to need to measure the unknown object's mass, and then we're also going to need to measure its volume. In addition to knowing this, you should also know to write down the word Isabella. Are you writing down the word Isabella? I hope you wrote down the word Isabella. After you've written down the word Isabella, move on to the next slide. Beep. The first thing you need to do is measure the unknown's mass. In order to measure the unknown's mass, you're going to use an analytical balance. I've put together a little YouTube video. This one was put together by moi on how to use the lab's analytical balances. Please take a watch. Also, when you get through watching the video, some of the things that you should remember from that video are to always make sure you turn off the balance when you're done with it. Make sure the doors on the balance are closed. Always remember to tare or zero the balance before you use it. Always remember to close the doors before you take a measurement, and record all numbers given to you by it. Also, make sure you write down the word Jeremy. I hope you're writing down the word Jeremy. After you've written down the word Jeremy, why don't you move on to the next slide? Oh, but not until you've watched the video. Beep. I'm assuming that you can measure something's length and width and height using a ruler already. That's something most people generally know how to do already. However, for most engineering work and a lot of chemistry work, a ruler just doesn't provide enough precision when it comes to taking measurements. Therefore, you have to use an instrument known as a caliper. A caliper, as opposed to being able to read things to the nearest millimeter, which is what most rulers can do, they can actually read things very accurately to the nearest tenth of a millimeter. So we're getting that extra precision, that extra sig fig. I've shown you in the pictures a caliper that I'm using to measure the diameter of a bottle cap. The first thing you need to realize about the caliper is that you put the thing you're wanting to measure inside that movable jaw there and you fasten it tight. After you do that, you're going to take your measurements. To know your measurements, you need to be aware that there's a fixed scale in centimeters and a movable scale in centimeters. Those are the two scales we're interested in. If you look at the top of that photo, where the tick marks are really longer and bigger, those are your inches. We're chemists, we don't work in inches. We're interested in working only in centimeters. The fixed scale is the part on the main ruler. The movable scale is the part that's raised there at an angle. Your instructions in the next couple slides are going to include references to the fixed scale and the movable scale. Move on to the next slide. Beep. In order to get the first part of your reading from a caliper, you're going to look at the movable scale and locate the zero. Do you see the zero there in the picture with the big thick blue arrow pointing to it? Now that you've looked at the zero on the movable scale, you're going to look at the fixed scale up and to the left of the zero. So I've located my zero on the movable scale, and now I'm looking up and to the left. The tick mark that is up and to the left of the zero is the 2.9 centimeter tick mark. See that thin blue line pointing to the 2.9 there? And you see how it's up and to the left of the zero? So, the first two parts of my measurement are 2.9 centimeters. So I know my bottle cap is at least 2.9 centimeters long in diameter. Now we need to get that extra sig fig. So let's move on to the next slide. Beep. Thank goodness for the iPhone's magnification power. One thing you'll discover is doing this in lab, you'll give yourself a little bit of eye strain. For the next step, to figure out that tenth of a millimeter or the hundredth of the centimeter, what you need to do is you need to look at all the tick marks on the movable scale until you find one that lines up perfectly with the number above it on the fixed scale. You want the two lines to look like they're one line. The numbers don't have to match, but the lines have to match. Those lines have to be perfectly aligned. If you look at the close-up of the photo, you can see that the 7 on the movable scale lines up perfectly with the 6 on the fixed scale. Those two lines line up perfectly. They look like they're one. Therefore, the number on the movable scale will be your next digit. Because the 7 lines up with the 6 and the 7 is on the movable scale, your next sig fig is the 7. So your reading would be 2.97 centimeters. This is also the part of the measurement where 2 lab partners could disagree, or 3 people could disagree. This is a really, really small, and you're looking at a really shiny object. So where you hold the angle of your calipers, or how far apart your eyes are all going to make a difference in where you see those lines lining up. So where I might see the 7 lining up perfectly, you might see the 8 or the 5 lining up perfectly. In this photo, it's pretty obvious, however, that the 7 lines up perfectly with the 6. So your 7's your next sig fig. Why don't you write down the word Flynn? Are you writing down the word Flynn? F-L-Y-N-N? Flynn? F-L-Y-N-N? Once you've written the word Flynn, move on to the next slide. Beep. Determining the density of an irregular object is a little bit more challenging and a little bit more fun. What you will need to do is you will need to follow the link to the LxWxH lecture, and after the LxWxH lecture, follow the link to the YouTube video so you can actually see the technique done in action. As long as you're at it, why don't you also write down the word Fletcher? After you've written down the word Fletcher, watch the LxWxH, watch the YouTube video. That's all, folks. Beep. Prepare your lab notebook for this lab. We're using a Dr. Kelly procedure today. So you'll need to prepare your lab notebook exactly as shown as in the attached PDF file. You'll find the attached PDF file called Sample Notebook in Blackboard. It's the same handout we saw when we discussed the lab notebook. We're going to use that procedure. So right away, go ahead and set up your title page. Set up your table of contents first, of course. Then go ahead and write up this lab in your lab notebook. Copy my title, copy my purpose, copy my procedure, copy my data table. And then you'll be ready for lab when it starts. Alright, that's it. Beep.